And this is exactly the problem I have at the moment with the Jaki battery. Too many cables, too many connections, too many apps. First of all, good morning and welcome back to another video here from the Off-Grid Garage Yes, good morning. Absolutely. It is 5 a.m. in the morning. No, seriously, when this video comes out, it is 5 a.m. in the morning. AEST, Australian Eastern Standard Time. That's when all my videos are being released. I always get up in the morning at 5 a.m. and release the video. Not just kidding, I'm just kidding. They are scheduled in YouTube, so I am still asleep at 5 a.m. but the videos will come out because most people are watching them now. And apparently this is good for the YouTube algorithm. In today's video, finally, Jakiper has sent me their USB to serial cable to RS232 cable finally to connect our computer to the battery so we can use the software and read out the BMS, all the parameters, all the settings, can have a look. When they sent this one here about 10 days ago from China, they also told me I can connect via RS485 to this battery. I'll just need another software for that to do that. So we are ending up with an RS485 and RS232 and a CAN connection at the same time. Now, you cannot just use RS232 or RS485. You actually need both. Yeah, I know, right? Because if you have only one of these batteries here, you actually don't need the RS485 cable because there's no communication to another battery. And on the other hand, you don't need the RS232 cable either because you only need this one here if you want to change the protocol. The CAN bus communicates with your inverter or your Victron system or your... I mean, the guys from Seplos, they managed to use only one app for that. And it connects via RS485 to your battery and you can change all the settings. And the same with the QSO battery. Even it has an RS232 port, you can change all the parameters and protocols via RS485. I mean, who is using RS232 these days? And yes, I'm wearing my blue computer glasses again tonight because I'm looking on the screen here next to the camera. And with my normal glasses, I always need to look like this because this is the multi-focus lens situation. Then I cannot read the screen because it's so up high and so close. So it always looks like this when I read the screen then. And with this one, I can just look in the camera and from time to time, I look on the screen and everything is sharp and crisp. Because a while back someone left a comment and said the blue glasses, they don't suit me. I mean, is this a fashion show here or what? We now have the Seplos app next to the Jambangda, the Tabaluga BMS, how I call it. And we also have now the Jakiper BMS RS485 tool. The PBMS tool, this is just for changing the protocol, but it only works via RS232. And we also have the Orient Power Tool software here to change all the parameters via RS232. If you connect via RS485, there's no way to change the protocol. So you need the RS232 cable only if you want to change the protocol. You can also use it to change all the parameters. Jakiper, come on! Do you think you can merge all these software applications into one like all the other manufacturers? So, okay, at the moment I've got my USB extension cable here, which plugs into another USB cable, which goes to our RS232 converter, which then connects to an DB9 adapter, which connects to the RJ11 plug. And this goes into our RS232 port of the BMS. Isn't that easy? So, and if you open the PBMS Tools software, we select COM9 because this is obviously the port I'm using at the moment. And we can see it connects right away via RS232 now, no problem at all with that. So firstly, we can carefully observe that there are no tabs here for any configuration or something. This only gives you an overview about the pack information, pack voltages, capacity, all the temperatures, and all the cell voltages. And the only purpose of this software here is to change the inverter protocol. So with this drop-down menu, we can select from the PACE IC, the pylon for the D inverter, Crowwatt inverter, and then we also have a protocol for pylon, but it is RS485, Crowwatt 485, and the Lux Power 485 as well. No Victron protocol, nothing. So I have not set any inverter protocol here at all, and the BMS is actually showing in Victron. So if you have a Victron system and want to use the Jakiper battery, you don't need this software, you don't need an RS232 connection at all, because you don't need to change the protocol. Before we leave this masterpiece of a software here, I want you to pay attention about the voltage difference tab here. Yep, just maximum, minimum voltage difference. Just keep this in mind. Okay, if we are connected with RS232, we can use the Orient Power Tools software app. It also uses COM9, it uses the same cable, the same adapter, the same RJ11 port. And here we can actually see that we have multiple tabs up here. So this software looks very similar to the one we looked at before. Just we don't have any possibilities to change the protocol here. I don't know why they haven't integrated this little bit into this software here and make it just one product. And because I made you pay attention that the other software showed actually the voltage difference, this one doesn't. At least not here in this position where it belongs. And maybe you can have a look at this software for a moment and can tell me where it is. Yeah, I don't know either. It is missing here. Okay, this is again a bit an inconsistency. Okay, let's jump right into it. The parameters of the BMS. We have to click on Read All. And here in the top left hand corner, we can see all the voltages on a cell level, next to it on a pack level. Then we've got the same for undervoltage on a cell level and undervoltage on a pack level. So very nice, structured, very intuitive, easy to read, easy to find. We've got our charge alarms and protection parameters down here, discharge alarms and protection parameters, all our temperatures, high and low, the balanced start voltage and the balanced accuracy. And here we have a Pack FullCharge Voltage. What? What did I just say? It is a Pack FullCharge Voltage we can set independent from all the other alarms and protection parameters. And we can also set a Pack FullCharge Current. Yeah, and I really want to do some testing with these two parameters, because I think, and I really hope, that these are the parameters we are all waiting for. That these two parameters are responsible to reset our BMS to 100% state of charge without going into a protection mode or without triggering any alarms or something. Just a voltage we can set when the BMS says, okay, if I'm at 56 volts and my charge current is under 1 amp, I am full, I show 100%. And the BMS does not disconnect because we have an overvoltage alarm or situation, because it is not necessary. These two parameters, these two settings are exactly what the Seplos BMS and the QSO BMS need. So I hope they are working. And here quickly on the right hand side, we've got the MOSFET temperature settings, the environment low temperature and high temperature settings. And you can also see I can actually change settings here as I like, but the Write All button is grayed out. It's not available. The whole BMS is locked down. Where was this one? At 3.5, I think. Jakiper also locks their BMS completely down. But if we go back in real-time monitoring, I have actually tried a couple of passwords, and the second one I tried was actually a hit 1, 2, 3, 4, 5, 6. And then it turns green. And when we go back in parameter settings, we can see the Write All button is now available. I tried the default password from QSO before and didn't work, and this one was the next one, because this is what the JK BMS uses, the Dali BMS uses, and was it the Overkill as well? I can't remember. Anyway, obviously this is not a secret, and I didn't ask them to give me the password. I didn't Google it. I just tried a couple of them and this was the one. So let's do a very quick rundown here on the important parameters. We've got an overvoltage alarm at 3.6, which is fine, and an overvoltage protection at 3.7, which is not so fine, because I put the specifications of the EVE LF100L, which are in the Jakiper battery, and the maximum charge is 3.65 for these cells and not 3.7. So this parameter actually needs to change to 3.65. Maximum charge allowed for this cell. And leave your comments down below if your Jakiper battery had the same 3.7 set in the parameters of your BMS, because this is not correct. I don't really see the point why we have Pack overvoltage protection as well, and because you can never exceed a Pack overvoltage and stay within normal parameters with your cell settings. It always triggers the cell protection first and never the Pack protection. But with this little tick box up here, we can actually disable all overvoltage Pack parameters and alarms. The undervoltage protection kicks in at 2.5 volts. This is fine. And again, we have got a Pack undervoltage protection here, which I found totally useless. So in theory, we can disable the undervoltage and overvoltage protection and alarms for the Pack level. And this is a 100 amp BMS. So we're getting an alarm at 105 amps, which I think is a bit too high. I would like to see the alarm at around 90 amps. And protection kicks in at 110. I mean, who is charging such a small battery with 100 amps? That is crazy. Discharge is exactly the same. 105 amps discharging alarm, which I would like to see at 90. Discharge overcurrent protection kicks in at 110. That is 1C for these small cells. And here, discharge overcurrent protection at 110 amps. Seems to be okay as well. It covers you for spikes. Temperature alarm at 60 degrees. Again, here from the specifications, it says 55, so this one is far too high. And the protection kicks in at 65. Again, far too high, 10 degrees too high. Discharge temperature, as per specifications, 55 degrees. These settings are too high as well. The balance threshold, I will set this one to a 3.45. And I want the precision to be as low as possible. If the balancer kicks in, let it balance. 20 millivolt difference is the smallest I can set. So it allows us to charge down to 0 degrees Celsius. Even this is per specifications. I would probably set this one to 5 degrees. And here the discharge under temperature protection at negative 20 degrees Celsius is as per specifications. Well guys, yeah, and then the Pack FullCharge Voltage at 56 volts. I'm really keen to try this one out here. So this looks like a similar mechanism as in the Victron Smart Shunt, where we have a voltage, a tail current and a time to set when the actual shunt resets to 100% state of charge. And we will try this out in a second here. MOSFET goes up to 110 degrees Celsius. If they think that's okay, I don't know. And we also have an environmental under temperature protection here of negative 20. This is a sensor inside the battery case again. And also an environmental over temperature protection of 60 degrees, which I think is far too high. If this is your internal case sensor and it is at 60 degrees, you cannot touch the case anymore. So you can see a few parameters are a bit especially the cell overvoltage protection parameter here, 3.7 volts was a bit too high. And I would really recalibrate most of the other parameters as well. Current, temperature, they are a bit too extreme, I think. Okay, anyway, let's click on write all, write these parameters back. And because I have pre-charged the battery already to 91% state of charge, we want to quickly charge it to 100% and see when the actual state of charge jumps to 100%. If it is at 56 volts, I'm really keen to see that. But I'm not going to use the RS232 software for it because of the missing voltage delta here. I'm not going to calculate the difference all the time while we are charging up this battery. Okay, and if you want to connect this Jakiper battery and BMS, the Pace BMS, to your Victron system, it's just a plug and play as you have shown in the first video. But the next day, the battery actually wouldn't connect to my Victron system anymore, and I couldn't find out what it was. Because I played around with the dip switches the night before to make the RS232 or 485 work, I had set all the dip switches back to 0 again, as per default, right? But if you do that, if you set them all to 0, your CAN communication is not working anymore. And the guys from Jakiper batteries told me actually I need to have the first one on and all the other ones off to make your CAN communication work. So if you do that and open the parameter settings in your Victron system, you can actually see there are numbers in there coming from the BMS. And you can let the BMS control your system now. As always, we've got 3 parameters in here: the charge voltage, the charge current, and the discharge current. So what parameters do you need to change in the BMS to set these parameters here in your Victron system? The charge voltage limit of 56 volts, that is very easy because this is our Pack FullCharge Voltage. So if I change this one here to 56.10 and write the parameter back to the BMS, you can see in the Victron system it changes to 56.1 as well. So there's no formula here, it is the exact parameter as we set it in the BMS showing in the Victron system. Big plus. The charge current limit is on 52.5, so we don't have any parameters here sitting on 52.5 volts. And we can see the charge overcurrent alarm sits on 105. So let's set this one here to 100 amps and write it back and see if the parameter changes. So the parameter in the Victron system is exactly half of what you have to set in the BMS. And I had a look in this drop-down menu. We can only go to 150 amps maximum as an alarm. So 150 is the maximum, which means 75 amps into this battery. I think that's okay. And we can see the last parameter, the discharge current limit is on 105 amps. And we've got the discharge overcurrent alarm sitting on 105 amps. So I assume this is the same parameter here, 1-to-1 without any formula. If we set this one to 100, we should see, yeah, it changes to 100. So this is 1-to-1. If I only want to allow the battery to discharge with, say, 70 amps. So that is very easy to change these parameters now here in the BMS, which are changing the parameters in your Victron system. Alright, so I have now connected our freshly repaired power supply to the Jakiper battery, positive, negative here. And we're charging up to 55 volts only and with 10 amps. Turn this one on. And we can see the 10 amps here in the software. Voltage is rising, but we cannot see any delta. Okay, let me close this software. Let's start the RS4855. This is open. See, this one is not working now because our dip switch number 1 is set to on. Otherwise our CAN communication doesn't work anymore. So if I get this one to 0, so and then it works. You know, I have to change the dip switch just to connect to RS485. But now the BMS is not communicating to my Victron system anymore. So this is totally... Okay, anyway, we want to have a look at the parameters. As we can see, the BMS has actually stopped charging. We are at 55 volts already, and we've got a deviation of 236 millivolt. This is as the battery came to me. And as you know, we have done 1 or 2 discharge tests so far, and I cannot see any balancing function happening here. I don't know if the cell number 7 gets actually balanced now. The only thing I can see is that my deviation actually increases. I can see there on the power supply we're still charging with 230 milliamps. It shows us the state of charge at 91%, but I believe we are far higher. We are at 55 volts. It seems to be a very, very unbalanced battery. The lowest cell is cell number 16 at 3.37. That's under 3.4. And the highest is over 3.6 already. See, it increased again by 2 millivolt. 190 milliamps going into the battery. And I don't think we can actually increase the voltage to 55.2, because then we will have an overvoltage protection situation for cell number 7. Very, very unbalanced. Alright, I'm not happy with that at all. The sticker came off again. So it is still cell number 7, 3.612. Another 5 millivolt on top. So cell number 7, And here we can see balance lead number 7. So if I can get my clamp around this, oh, easy. So we can see nothing. It's actually not balancing at all. There's no balancing. The balancer on the Pace BMS is not working at all. There's no animation in the software and I cannot measure anything at all. No balancer. No, nothing. I have now changed the balance start parameter to a 3.4 volt, but there's still no animation, no indication if the balancer actually works. But the voltage delta is rising. 247 millivolt now. 3.61 volts. Okay, so I think without putting an active balancer into this Jakiper battery, we will not be able to charge it higher than 55 volts. And I really want to test the Pack FullCharge Voltage and Pack FullCharge Current situation parameters here. So I'm currently discharging the Jaki battery with our power supply and just putting some energy into the AO lithium battery because this one is below 30%, just a dump load. I just had to get rid of some energy so we can recharge it and see if it actually resets to 100%. It's always chasing these 100%, right? And I want to show you the parameters here. So I have set 55 volts as our full charge voltage and 500 milliamp as our full charge current. So in theory, if we meet these two criteria, we should reset to 100%. At the moment we are at 90%. So I'll turn on the charger now. There we go. We are charging with 10 amps. And we have to observe here the pack voltage at 55 volts. And once the current goes under 500 milliamps, we should see the state of charge here going to 100%. This is my theory. All right, we are at 54 volts and deviation has increased to 26 millivolt. It's not too bad, but now we are coming slowly out of this flat area of the curve into this deep, into the knee, and we'll see the deviation is increasing fast now while the voltage is rising to 55. Still charging with 10 amps. Ah, look at this. Now the balancer comes on. BL. It didn't do it before. It didn't balance at all. Is it a charge balancer? Maybe only while charging it balances? Oh wow, guys. Okay, let's quickly measure cell number 7. And 0. Let's see if we can measure anything here. 60, 70 milliamps balance current. That's all. 50, 60 milliamps. All right. Oh well, this is disappointing. Okay, we are almost at 55 volts. The current is slowly tapering off now. We are going into an absorption phase. And look at this cell deviation, 170, 180 millivolt now. Totally crazy. So we should hit the 55 volts. Let's see once the current goes to 0 if the balancing function actually disappears. We've got an high voltage alarm in cell number 7 now. Still charging with 1.3 amps. We are slowly increasing the voltage to 55 volts. Power supply says 1.4 amps. Here we can see 1.1 amp. And I've got the bad suspicion as soon as this one hits 0 amps here, because we are under the threshold what the actual BMS or the shunt can measure, we will see the balancing function disappearing. That would be a total nightmare for this BMS. Okay, we are still not at 55 volts. We will see the pack current going down to 0 any moment. There, it is on 0 and the balancing is going away. Ah, Mr. or Mrs. Pace, whoever made this BMS, this is the worst you could possibly do. A charge balance with such a large battery. we are charging with 10 amps or something into the battery and the balancer is only 60, 70, 80, say 100 milliamps, it won't make a difference at all. It won't make a dent. And now we've got the situation, no current is going into the battery. The cell's sitting on a higher voltage here, totally unbalanced, and the balancer is off because we are not charging anymore. This is a relict from lithium-ion cells battery chemistry, because there you have a linear curve to your state of charge, because your voltage is constantly rising until you hit the 100%. But here with lithium iron phosphate, this method does not work at all. 610 milliamps, the power supply shows me, are still going into the battery, so the cells are actually still charging, but the BMS doesn't show the charge anymore because the current is so low. Okay, so this makes the whole BMS completely useless to me. So we need to wait until we hit the 55 volts now. I probably increase the voltage just a tiny bit by 10 millivolt, because otherwise it may take a long time. Okay, I changed it to 55.02. So let's see, 55 volts. There we are. And we are on 0. So this one should reset to 100% now, shouldn't it? Come on, BMS, come on. Show me the 100%. I mean, we are still charging with 550 milliamps into the battery, but the BMS doesn't know because it doesn't measure. We are still at 91%. We are now down to 510 milliamps charging current. And look at this deviation, 250 millivolt. And it's not decreasing anymore because the balancer has now turned off. It doesn't do anything anymore. And it also does not reset to 100% as I hoped for. So now you are completely stuck with this battery actually, because you cannot charge it any higher. Otherwise you're getting into an overvoltage protection situation with cell number 7. And it also doesn't rectify the situation because the balancer is off. Because we are not charging anymore. I mean, really? That is almost a deadlock now. And these cells, they will not balance when you take 50, 60 milliamps away with every charge cycle you do. They will not balance. We have tested this here on the channel. This is not going to work. All right. Well, this is a total fail for this BMS. I was really excited about this Pack FullCharge Voltage and Pack FullCharge current here. Set them to 55 and 500 milliamps and it resets to 100%. It says, okay, these are the parameters which I need to hit the 100%. But as you can see, it still sits on 91%. Doesn't go to 100. Okay, I'll turn up the power supply just a tiny bit. 55.1. Okay, as soon as we can see current, the balancers actually kick in again. But I think we will have an overvoltage disconnect here very soon. Still no 100%. We are far over 55 volts. And we should now be under, we are under 500 milliamps. Still no 100% state of charge. It doesn't recognize the battery is fully charged. So what the hell are these parameters for then? I have no idea. (270 millivolt deviation we have, and 6 and 7 are over 3.6 volts. So if I just go a tiny bit higher with the voltage, we will have a disconnect with cell number 7. Well, guys, there's nothing happening. It's not resetting to 100%. Okay, let's go a bit higher. So cell number 7 actually triggers the overvoltage protection. 55.2 volts. And we should see this here at 3.65 volts any moment. The balancer is on. Here we go, 3.65. Yep. Charged MOSFETs have turned off. Charging has stopped. Everything has stopped. And now the state of charge has reset to 100%. So it needs to trigger the protection parameter again to reset to 100%. So this again totally sucks donkey balls. It says now the battery is full. We've got a protection status. We've got an alarm status. Let's measure the relay again. So just as a reminder, it says here pin 3 and 4 always open, will close with fault or protection signal. So this is 3 and 4 on this side. And we clearly have an alarm and protection status at the moment. Okay. In the last video, people gave me a hard time because I measured on top of the screws here. And people said these screws may not have contact with the actual terminal, but they do. So I measure the terminal and the screw. See, we've got perfect contact. So it doesn't matter, but I can measure directly the terminals here, or we can even take this sucker out and measure directly the pins coming from the relay. There's nothing. There's nothing. Nothing. There's no connection to anything. This is absolutely not working. Fake. So I really like the battery and the whole setup, the installation, the workmanship. This is all very good quality. But the BMS here, yes, exactly. Look at all this cabling mush here. And to access the battery with RS485, you have to set the dip switch all to 0 again. So you could say, well, then you use RS232, right? Exactly, you can. But if you have like 5 of these batteries and you want to change one parameter, you have to change your cable from one battery to another and change your parameters and settings individually for each battery. So the pace BMS inside the Jakiper battery, big thumbs down so far. So I have now switched software to the RS232 software, which doesn't have the delta, but it doesn't matter because we have disconnected the battery anyway. Due to an overvoltage situation in cell number 7. Going back to the parameters, the Pack FullCharge Voltage, 55 volts. So this is exactly what you can see here in the Victron system as well. And if you would let the BMS control your system, it would make the MPPT or your inverter to charge to 55 volts only. I'm not sure what the full charge current is for then, if it doesn't reset to 100%. But as we have tested, it doesn't. And once you hit the 55 volts, you can see this here in the Victron system again, the charge current from the MPPT or your inverter would go to 0 amps. So this system actually would work then. And it would not disconnect your battery with an overvoltage protection or something. It would just charge to this 55 volts and that's it. So that's actually pretty good and working. But then you would end up with a state of charge of 91%. At least this is what the system would show you, because the BMS still doesn't reset to 100%. And this is obviously a problem which goes through all these BMSs. Starting from the Seplos BMS, which needs an overvoltage protection trigger to reset to 100%. The same for the QSO battery with the Tagaluma BMS, and now with the Pace BMS in the Jakiper battery as well. They all need to trigger the overvoltage, so you need to go into the extreme of 3.65 volts with one of your cells to actually reset to 100% state of charge. And none of these BMS manufacturers get this right. Your state of charge showing by the BMS and your inverter and your system will always be around 91% only, even the battery is fully charged. It would never reset to 100%. So if you are a customer and see that saying, well, my battery is at 90% only, but the charger has already turned off for some reason, you would call the company you bought this shit from, right? And would complain the battery does not charge over 90%. I don't know why it is so hard to change the software to reset to 100% at some kind of parameter. I mean, this BMS has already a full charge voltage parameter and a full charge current parameter. Why not use these two in combination to reset to 100% when they are reached? Why do we need to charge higher than these set parameters to get to 100% and trigger an overvoltage protection of one of the cells or of the whole pack? That is totally stupid, and I really cannot believe nobody gets this right. Anyway, guys, it is what it is. I can only test here and make the manufacturer aware of the flaw and what they need to improve. And we are still yet chasing this BMS, which actually does it right, which resets to 100% before it actually triggers an overvoltage situation. And the fix for all these manufacturers, Seplos, QSO and Jakiper now, it is just a software update away. Then you would have the perfect BMS, apart from the missing active balancing, of course. Okay, guys, I'll take all these information and get them back to Jakiper. Also the non-working relay function. And I will inform you either down in the description or in another video then, once they get back to me with a reply. As always, guys, thank you so much for watching. Thanks for all your great support. Thanks for all your generous donations, buying me a beer here in sunny hot Australia. It is very much appreciated. And until the next video, guys, when we start our big new project here, which will be so much fun. At least I hope so. You stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Yeah. The Pace BMS.